devices. Additionally, the magnetic storage is non-volatile. Types of magnetic storage devices. Hard drive. A hard drive, commonly identified as a hard disk drive, is a device that can store more than 200 GB of magnetic data. It has a stack of disks set on a solid cover that is pinned quickly for quick retrieval. A safe and dependable storage solution is provided by the fact that the data is not lost when the power is turned off. Floppy disk. In 1969, IBM introduced the first floppy disk, a hardware data storage system used by personal computers. These 2 mm thick, 3.5-inch. Let's talk about floppy disk. In 1969, IBM introduced the first floppy disk, a hardware data storage system used by personal computers. These 2 mm thick and 3.5-inch square plastic cartridge coated with iron oxide were used to store magnetic data like hard disk. However, they are now considered unnecessary. Magnetic tape. In 1928, Fritz Pfleumer invented magnetic tape, which was primarily used for voice recording. It's conventional technology, although CDs and DVDs have replaced it. Optical media drives. Let's talk about CD and DVDs. CD-ROM refers to compact disc read-only memory and is a type of technology that falls under the random access category. These discs have a storage capacity of 800 MB for digital data. These data cannot be accidentally discarded. Blu-ray. Due to the proven fact that DVDs have a data storage capacity of 25 to 50 GB and can store double the amount of the data that the Blu-ray disc can, they have completely supplanted Blu-ray disc. Blu-ray CDs are used to store HD high-definition videos because of their large storage capacity. Solid-state drives, USB flash. USB flash drives, USB thumb drives, and USB sticks are lightweight, plug-and-play portable storage devices that have replaced CDs. They can hold crucial files, folders, or data, allowing them to be easily plugged into a computer's USB port. Let's talk about data representation in a computer system. Types of data representation. A piece of data such as number, character, picture, sound, video, etc. is represented by a computer using certain amounts of bits. Data representation is the process of storing information internally in a computer. Binary digits are the standard method for representing numbers and other data in computers. Words of the same length are grouped into strings of bits in the computer memory. Instead of being represented as integers or floating points, decimal numbers are first transformed into binary versions. Types of number system. There are 4 main types of number systems: binary number system, octal number system, decimal number system, hexadecimal number system. The base of decimal number system is 10, the base of binary number system is 2, the base of octal number system is 8, and the hexadecimal base is 16. Let's talk about binary number system. The transistor, which is an essential component of a computer, serves as the storage unit for bits. It simply has 2 states, on and off, which allows it to on or off the current flow. There are 2 symbols that may be used to represent these 2 states, and they are 1 and 0. This indicates that the basis of binary number system is 2. Every number may be represented using just symbols. We use set of ones and zeros to represent numbers rather than individual units. Here's an example of how computer counts from 1 to 10 binary number system. Let's talk about decimal number system. The decimal number system is one encryption most commonly used. Data can be encrypted to make it unreadable to all the parties aside from the intended receivers. Any quantity. The process of converting plain text in system, which can be read by humans into ciphertext that can be read by humans. Is non-technically uses base 16 to represent different encryption essentially. Hence, this number modifies all the readable data to make it appear random. For encryption, a cryptographic key or set of numbers that both the senders and recipient of an encrypted message agree upon is required. Types of encryption. Symmetric encryption and asymmetric encryption are the main types of encryption. Let's talk about symmetric encryption. Symmetric encryption uses a single key to encrypt and decrypt. For example, if you encrypt a zip file and decrypt it with the same key, you are using the symmetric encryption. Asymmetric encryption, it's also called public key cryptography. It's the field of cryptographic system that use pairs of created keys. Each key pair consists of a public key and corresponding private key. Asymmetric encryptions allow users to encrypt information using shared keys. Decryption. Decryption is the reverse process of encryption. It uses the correct algorithm and key to convert ciphertext back to the plain text. This phrase might refer to a technique for manual decrypting data or for decrypting data using the right codes or keys. To make it more difficult for someone to steal information, data could be encrypted. Some businesses additionally encrypt data to safeguard corporate information and trade secrets. It could be necessary to decrypt and the data if it needs to be seen. In the absence of decryption passcode or key, a specialized software may be required to crack the decryption and make the data legible. The durability of encryption algorithms and the security of keys are essential components for ensuring the security of encryption and decryption. Coding system. There are four main types of coding system. Binary coded decimal, BCD. American stands code for information interchange, ASCII. Extended binary coded decimal interchange code, Unicode. Let's talk about binary coded decimal, otherwise BCD. BCD is a method of transforming decimal values to binary counterparts by employing a binary encoding of either 4-bit or 8-bit. This quick and effective approach is employed in digital displays when the data processing is difficult. BCD is an important procedure in data representation since it treats each digit as an independent subcircuit. The 8421 BCD code encodes the weights of various bits in 4 bits groups, beginning with the MSB and going to the LSB. This balanced code reduces fractional mistakes and is used in huge financial calculations to represent data efficiently and accurately. Here an example of BCD. American Standard Code for Information Interchange, ASCII. The computer version of Morse code or first attempt at it is ASCII. Unlike ASCII, which was created to represent up to 128 different characters in just 7 bits of data, Morse code can only represent 36 different characters, 26 letters and 10 numerals. The English alphabet's 52 upper and lower case letters are represented using ASCII, which is case sensitive. Here I have added the table of ASCII code. Unicode. The Unicode standard was created to unify the different encoding schemes, aiming to minimize confusion between computers. The Unicode system was designed according to a standard to represent 65,536 different symbols of 16 bits. Unicode is a standardized character encoding program that gives each letter, symbol, and a script used in written communication across several languages and computing systems a distinct numeric code. Being able to interchange and show different script, alphabets, symbols, and emojis make Unicode an essential tool for global communication and computerized text processing. These are examples of Unicode. Images and sound representation in a computer. Images. Digital data is used to represent images and sounds in a computer. Images are represented in a computer as groups of pixels. The color of information in each pixel determines how it appears. The amount of pixels in an image is determined by its resolution, and images with greater resolutions are sharper and more detailed. The RGB, red, green, blue model is frequently used to represent colors, where each pixel's color value is a mixture of these three fundamentals of color. These colors values are saved by the computers as binary data, typically in a format like JPEG, PNG, or GIF. While retaining picture quantity, these formats use a variety of compression methods to minimize the file size. Sounds. Analog to digital waves are converted into digital representation during the analog to digital conversions process. This involves taking sound wave pictures and measuring their amplitude. This ensuring digital samples are represented as numerical values with the sampling rate commonly measured in kHz, decading and original sounds repeatedly. The dynamic range of amount of detail is determined by the bit of depth employed to represent amplitude values. WAV, MP3E, MP3, and AAC are digital audio formats that employ compression techniques to minimize file size while preserving acceptable audio quality. Data compression. Data compression minimizes the amount of bits required to represent data, conserving storage capacity, increasing file transfer speed, and lowering storage hardware and network bandwidth expenses. Text compression entails eliminating redundant characters, introducing repetition characters, and replacing frequently occurring ones with small pieces. It has ability to reduce the size of a text field by 50% or more of original size. Data transmission can be done on individual data items or on a full transmission unit that including header data. Larger files can be delivered or received over the internet in zip, gzip or other compressed formats. Application of data compression. Data compression is widely used in various domains including file compression, image compression, audio compression, and video compression. Examples for file compression: SIP, ZIP, GSIP, gzip, RAR, and 7Z formats. Examples for image compression: JPG, PNG, and GF formats. Audio compression: MP3, AAC, and OGG. Video compression: MPEG, H.264, and HEVC are examples for video compression. Data compression. We can categorize data compression type into two parties: lossless compression and lossy compression. Let's talk about lossless compression. Data compression can be either lossless or lossy. When a file is uncompressed, lossless compression allows it to be restored its original